All right, so this is a Coulomb's law problem. We got three charges around the perimeter of an equilateral triangle. We're going to call this guy charge 1. We'll call this guy charge 2. And we'll call this guy charge 3. He's negative. Now, this problem wants us to find the net force on this guy. Could the question have asked us to find the net force on that guy? Yeah, or that guy? Yeah, but it didn't. The question wants us to focus in on this 7 microcoulomb charge. So you look at this. So let's go through them one by one. What's charge number 2 doing to charge number 1? Attracting or repelling? Repelling. So there's going to be a force like that, and we're going to label this force F21, which is the force of 2 on 1. And now what's charge 3 doing to charge number 1? Attracting or repelling? Attracting. Opposites attract. So this force is coming down like this towards charge 3. And we're going to label this F31. Now just be aware, the other 2 charges here are also experiencing forces. Like, for example, what's charge 1 doing to charge 2? Repelling. So there'd be, if we were focusing on that guy, you know, this would be F12. F12, this force is equal and opposite to this force. All these forces are equal and opposite to each other. Let's just look at one more. So this was F12. How about this guy right here? What's this guy doing to charge number 2? Attracting. So this would be F32, the force of 3 on 2, which is going to be equal to this force right here, which we'll call F23. And then this guy right here, we have F13, like that. But anyway, we are focusing on charge number 1 because that's what the question tells us to do. So first thing you got to do is use Coulomb's law to find out what these forces are. We got to find out what F31 is, so we're going to solve for F21 and F31. Now for sake of time, I'm just going to kind of talk about how you do it. All you're doing is you're plugging into the equation for force between charges, which is Coulomb's law, KQQ over R squared. So for example, if you're solving for F21, you're going to plug in K, which is 9 times 10 to the 9th Newton meter squared over Coulomb squared. And then you're going to plug in for this charge here goes there. But are you going to plug in 7 microcoulombs? No, you got to plug in, you got to go 7 times 10 to the negative 6. You got to take it to coulombs because in the Coulomb constant, that's coulombs. It's not microcoulombs. And then the other charge we're going to plug in is 2 microcoulombs, 2 times 10 to the negative 6. And then the distance from center to center is 0.5 meters. So you plug all your values in. I don't want to bore you with watching me do it because that's really not the main part of the problem. The main part of the problem is vector work. So F21, if you punch it in correctly, F21 comes out as 0.504 newtons. And then F31, the force between charge 1 and charge 3, comes out as 1.008 newtons. Now, the rest of this problem is not electrostatics. The rest of this problem is vector. To erase that, we're going to make some room. Let's grab this, kind of blow this up. Okay. The rest of this problem is vector. So we know that F21 is 0.504 newtons. We know that F31 is 1.008 newtons. Okay, you got to break these into X component and Y component. X component, Y component. These angles are 60 degrees because what we're trying to do is figure out the total force on this. So here's what you do. Actually, we don't need that. Let's delete that. All right, so what I'm going to do, I'm going to find out the total X force by summing forces in the X. I'm going to find out the total Y force by summing forces in the Y. How many X forces are there? 2. We got this guy and we got this guy. All right, those are the 2 X forces. So this is going to look like cosine 60 times 0.504 plus cosine 60, 1.008. This gives us a total x equal to 0.756 newtons. That is our total x. Okay, for the y direction, we have this guy and this guy. We have two y forces. So summing the forces in the y, we'll start with this guy. You're going to go sine 60 times 0.504, and then minus sine 60, 1.008. This right here is this guy. Okay, this adds up to negative 0.43648. We're almost done. So now what do? We have this is our total x, this is our total y. What do we do to our total x and our total y? Tip to tail. So just go bam, here's our total x, 0.756 newtons. Here is our total y. Just make it a little shorter because it's not as big. 0.43648. The total force is going to be this hypotenuse right there. So how do we do that? Pythagorean Theorem, which you don't have to watch me do it. Just do this squared plus this squared equal to this squared. All right, so this comes out as 0.873 newtons. And then we need this angle. So to find that angle, just go tangent inverse opposite is the 0.43648. The adjacent is 0.756, like that. It comes out at 30 degrees. Now, are you just going to say 30 degrees? No. So it's like this. Here we have x and y. Our final force is pointing down like that. So how do you express that 30 degrees? You'd say 30 degrees below positive x. So here's the final answer. That's mainly a vector problem.